So today we are going to discuss chapter number 4, that is arrangement in this book, chapter number 4. So in chapter number 4 I'll give you only one concept, and that is n articles and distinct articles can be arranged in n factorial ways. Then I have introduced a new method, that is SATA, select and then arrange if required. So you will not get confused whether you have to use permutation or you have to use combination. Select and then arrange. So no more concept in this particular chapter. We'll start with the example directly and we can solve. Let's see. Example number 1. It says that in how many ways 10 distinct objects can be arranged in a straight line? It's a very easy question. Since n is equal to 10 given to us, so how many ways we can arrange these 10 distinct articles in a straight line is equal to 10 factorial ways? Definitely, it's a very easy question. Now let's see example 2. Discuss example 7. It says how many ways 20 students can be arranged in a straight line such that 3 students A, B, C are always together. Similar to that previous question, total number of students are 20 and A, B and C are always want to be together. So first diagram with a string, how many ways we can do that? 3 factorial ways. Because A, B, C themselves can be arranged in 3 factorial ways. Then how many distinct elements we have? We have total 18 distinct elements that can be arranged in 18 factorial ways. The total number of ways that we can arrange in this particular fashion is 3 factorial into 18 factorial. Then example 8. Example 8. It says in how many ways 20 students can be arranged in a straight line such that 3 students A, B, C are always together and C is always ahead of B. Okay, in the previous example we have seen that total number of ways that we can arrange them, these 20 students such that A, B, C are always together is 3 factorial into 18 factorial ways. But in this particular example, what we have to see that ABC are always together, C is always ahead of A and B. So why this 3 factorial we have taken? Because ABC themselves can be arranged in 3 factorial 6 ways. Just have a look at this. Either it is ABC or ACB or BAC or BCA or CAB or CBA. Total 6 ways that these 3 can be arranged. Out of 6 we need, what is the condition? C is always ahead of A and B. Means in this particular question the favorable cases are only these 2. Means out of every 6 cases only 2 cases are favorable. So by simple unitary method, total number of ways is given by this divided by 6 or 3 factorial into 2 or 18 factorial into 2 ways. Example 2. That says in how many ways, example 2. It says how many ways 10 distinct articles can be arranged. Not 10 distinct. In how many ways 10 identical objects can be arranged in a straight line. This formula is applicable only for distinct articles, not for identical articles. So if identical articles, then how many ways we can arrange them? Only one way. Right? Because they are identical. Let's assume that there are 3 A's. So how many ways we can arrange? Only one way. Doesn't matter which A you are writing before or after. Always result will be similar. So in this case, how many ways? Only one way. Then see example number 3 in the book. Example 3 says in how many ways 7 students can be arranged on 10 chairs in a straight line. So number of students is equal to 7, but number of chairs is equal to 10. So how many ways will arrange them? So here comes the SATA application. And the SATA rule selection of means first select and then arrange. Number of chairs is 10, number of students 7. So out of 10 chairs we have to select first of all 7 chairs. How many ways we can do that particular selection? 10, C, 7 ways. So first we have selected the chairs. We have claimed the chairs or whatsoever. So out of 10 we have selected 7 chairs in 10 C 7 ways. Now we have 7 students and 7 chairs. How many ways we can arrange them? Is 7 factorial ways. By formula this is only equal to 10 P7. So don't get confused when you will use C or when you will use P. Just assume there is no P directly. First you use C and then see whether you have to arrange them or not. If yes, then arrange them. Let's see question number 4. This was example number 7, example number 4. In how many ways 7 prizes from 1st to 7 can be awarded to 10 students? Okay. So example number 4. In example number 4 is given that number of prizes are 7, but number of of students are 10. Prices are 7. But students are 10. Okay, tell me now, what you will do. First of all, the first action that you will take, okay, out of 10 students, you have to select 7 students. Like in SATA application, select and then arrange. So out of 10, you will select 7 students. How many ways you will do that selection? 10 C 7 ways. So you have made a selection of 7 students and 7 prizes. How many ways you can distribute them or arrange them? Is 7 factorial ways. That means 10 P 7. Don't use this P directly. Use always C, and then just see the condition. If it is you have to arrange, then arrange them, and then finally come to the P. Don't directly use P. Otherwise, you will get confused again that whether you will use C or you will use P. Then next we will discuss example number 5. Example number 5 says, in how many ways 20 students can be arranged in a straight line if two particular students A and B are always together. So total number of students are 20, but A and B are always together. So this is also called a string method. String method means tie A and B together with a string. Right? So how many ways we can do that? In 2 factorial ways we can do that. Means A is before B or B is before A. So total 2 ways. Now if you have tied A and B together with a string, so out of 20 you have removed these 2. How many remaining? 18, and then you have added a bunch of A and B. So total number of distinct elements we have is 19. These 19 distinct elements can be arranged in how many ways? 19 factorial ways. So total how many ways we can arrange these 20 students if A and B are always together is 2 factorial into 19 factorial ways. That was example number 5. Example number 5. Now example number 6. Example number 6 says, in how many ways 20 students can be arranged in a straight line if two particular students A and B are never together. This is just reverse of this case, complement of this case. So total number of ways we know that 20 students can be arranged is 20 factorial ways. But out of 20 factorial, these many are the ways where A and B are always together. So how many ways A and B are not together? Is 20 factorial minus 2 factorial into 19 factorial ways. That means 20 into 19 factorial minus 2 into 19 factorial. That means 18 into 19 factorial ways.